Hello, welcome to this afternoon's webinar brought to you by Napit and hosted by ECN Interactive Week. My name's Paul Chaffers, I'm the Technical Events Manager at Napit, and joining me is Frank Bertie, our Chief Technical Officer. Today we're going to be looking at EICR observations and codes, and we'll bring up some real life pictures, and we're going to point out what the defects and what the observations are, and we're going to give you an opportunity to code them. Frank's going to be keeping an eye on the chat box. Drop your codes in there, and then we'll reveal the code and see where we go. Now, just to point out before we get underway, both myself and Frank work in the JPAL 64 committee structure. So that's the committee that's responsible for writing and maintaining the wiring regulations. And both myself and Frank are deputy chairs of, Frank sits on subcommittee A, as well as the main JPAL committee. And I'm deputy chair of subcommittee B, which looks after the thermal aspects of the wiring regulations. Okay, so now we've got that out of the way, let's start having a look at the codes. We always do a little reminder of what the codes mean, because over the years people get confused with when we had periodic inspection reports, then we had electrical installation condition reports, people get the codes muddied up. So we always find it's best to just have a review of that before we get underway. Now, Napit has got an industry-leading coding guide called the EICR Codebreakers, and in there they give lots of different observations and what the likely code is. And when we say the likely code, you're the inspector on the day. It's good to have guidance, but sometimes you need to adjust it. If there's something on site that concerns you slightly less, that's your right to do that as the inspector. Okay, so code 1 means danger present. That's risk of injury, immediate remedial action required. Now, we use a traffic light system with our presentations and with the Napit Codebreaker, and C1 is the most dangerous. You have to do something. You've got a duty of care. You can't just leave this danger present where somebody could get electrocuted or a fire could start. You need to warn somebody, so you have to pack there. And we advise our inspectors to make sure that they in place, so that they've got a client they can go to. If they find a C1, what do you want me to do about it? They can hand over a dangerous situation report, or it might be that the client has given them permission to make C1 safe. So that conversation has to happen before the start of the inspection, really, so you know where to go with it. Now, next up, and that's for potentially dangerous situations. It's still very urgent and it's still unsatisfactory, but it gives the customer a pecking order. When you look at C1s, it's danger now, it could kill me now. C2 is something has to happen before that becomes, it's likely to be dangerous very soon, but it's not immediately dangerous. So it's a pecking order for the way that the customer wants to address these problems. C3 is improvement recommended. Now you'll notice this one's gone into green, and that's because if you only have a report with C3s on them, it's a satisfactory report. And a C3 is where the inspector feels that there could be an overall improvement made that will enhance the safety of the property, but it's not unsafe for continued use. And then we have an FI, which is further investigation required without delay. Now, here's the important thing. When we used to do periodic inspections back in the day, you could use an FI, but unless the report had a C1 on it, it could go through as a satisfactory report. And quite often, things that needed that further inspection didn't get attended to. With the EICR, if you issue a further investigation code, then there needs to be, or the report can be turned to satisfactory. So C1, C2, FI is an unsatisfactory report, and a C3 can be satisfactory. Okay, so let's have a look at our first observation. So in this picture there, you can see we've got bypassed RCDs. If you look at the right-hand side there, you can see that there's no cables feeding the RCD whatsoever, and the cable feeds a 40 amp B-type MCB, which then goes on to feed the other circuits on that side of the board. And there's a similar sort of fashion on the other side. Now, for the purpose of these pictures, imagine we've took the covers off of the distribution boards. So the observation bypassed RCDs, the fact that circuit breakers are used as isolators there, and we've also got the situation where we've got the neutral bars have been joined, so they're not split load, and therefore if you was to isolate the right hand breaker, you've still got that common connection there on the neutrals. that could cause a problem as well. So I'm going to ask you to vote on what code you think it is, whether you think it's a danger present, C1, or whether you think it's potentially dangerous. See if I can open up the chat and see if we've got any codes coming in. Anybody want to join in? Can you see anything there, Frank?
Yeah, we've got a few coming through.
Yeah, what we got?
C1s.
C1, C2s. Okay. What we're going to do now then is we're going to reveal the code, and then I'm going to ask Frank to explain why it is this code we've given. Okay, over to you, Frank.
We've got a C2, and it is because it's potentially dangerous. The isolators, the circuit breakers uses isolators, but it is potentially dangerous. The protection is still there. We have to have something else, other faults happening in that installation to make it dangerous. Potentially dangerous.
Okay, great stuff. Obviously, there's no additional protection from the RCD, so there's no additional protection there. Should something happen, it's not there. That's where that potential for danger is. So we're going to try and explain this as we go through, and hopefully at the end of it, you'll find it a very useful CPD session. Next up. Okay, this one's quite straightforward, really. You can see you've got, not sure if that's an old voltage kind of trip there on the right-hand side, Frank, but some sort of device where the terminal cover's been left off at the bottom. And we've also got strain on the terminations on the meter towers. Now, I think it was with the 18th edition, a note went alongside the regulation that talked about cables must be protected against strain. They must be supported and not liable to any sort of damage. There was a note added to say that that also included consumer unit meter towers, because quite often you'd see meter towers flapping around and it's really not satisfactory. But in this case, we're going to code the fact that there is access to live terminals. Would anybody like to guess what code that is? Have we got any coming through?
Yeah, a few coming through. They're coming through C1s at the moment.
C1s, C1s, yeah, absolutely right. We give that a C1 purely because there's danger present. Okay, next up. Right, we've got an incorrectly sized shower supply cable. Okay, you can see that at the bottom there, it's about a 1 mil, maybe a 1.5 mil, and you can see the shower terminals have got quite a sufficient size cable there. So it's quite obviously done by somebody that wasn't electrically skilled. And I can't see the shower, but we need to assume that it's quite high in its loading demands. 1 millimeter cable is liable. Clip direct is only going to be good for about 16 amps. That is at a minimum of 32 amp shower, maybe even more. What are we going to code that one as? Okay, so you're an inspector there on the day. You're looking at it. You're saying, is there any danger present? Is the cable burning? Is it liable to sort of burst into flames at any time soon? Or is there a potential that it might happen? That's the kind of questions you've got to have. But we've got anything coming through there, Frank?
Nothing coming through at the moment.
Okay. Well, we're trying to make it interactive, but if not, we can just...
couple FIs, couple C2s, C2, FIs.
Okay. We've given it a C2. Again, this has got all the potential for a problem. But at the time, there's nothing on fire. There's no thermal damage, no evidence of thermal damage. But I get it. Some inspectors of FI, they might want to, do a more thorough inspection of that circuit, make sure the switches are checked, etc. But in this case, looking at the picture, we're going to say it's got the potential for danger. So C2, potentially dangerous. Okay. Now, next up, we have got a situation where we've got a consumer unit that's been sort of configured incorrectly. Now, we've got incorrect RCD coordination where we've got type AC RCD. So you can see that there actually are CCBs, those RCDs in the board there, and you can see the little alternating current symbol, the type AC symbol there, and it's feeding some RCBOs that appear to have a type A characteristic. So what I'm going to do is I'm going to ask Frank to sort of try and explain why these different types of RCDs have come about. So we're starting to see a lot more type A's, and maybe Frank, you could explain what they deal with.
Yeah, the reason we've got a different type of RCDs now, because we have a lot of DC currents within electrical installations through different types of equipment. Electric vehicle charging points is one, solar PV is another type of installation where DC currents can be present. And what tends to happen with the DC currents, they tend to saturate the coil within the RCD, and they could mask any potential faults that were occurring in the installation, and that would mean the RCD could fail to trip. So the DC currents can have an effect on it. So the standard types of RCDs, which we normally put in every place for type AC, the format in one. Now you've got the other options of type A's to come in, which cover some types of DC currents, and depending on the scenarios, it could go up to either a type B or a type F even. And as you get into the different type of RCDs, the cost difference is quite higher in some cases. Certainly in the type Bs, they tend to be quite a bit dearer. But the type A's you're starting to see them in a lot of the configured consumer units. You'll start finding it's type A RCDs that are put in these now because of those situations. The manufacturers are starting to supply the type A's as standard as opposed to the type ACs.
That's very true, Frank, and I believe the DPC for Amendment 2 as now starting to recognise type A as more of the general purpose type of device, and I think if I remember rightly, there was a note or something warning that unless you knew the load was, didn't have any DC components in it, such as a standard heating element or something like that, then you shouldn't use a type AC. So moving forward, we're going to see a lot more of type A devices. Now, what we've got to do is we've got to look at how dangerous is this then. So let's imagine we had an MCB sat on one of those spare ways and it was relying on that type AC RCD for its additional protection. Should a load with DC in it mask it? Let's say that those RCBOs have been put in for a particular application. Should any of that DC mask the AC device? When there's a problem on the MCB that I've said, let's imagine the circuit's in place, the type AC RCD may not trip, as Frank has already said. So if that was the case, this may have a potential. But in this scenario, every single circuit has got RCD protection, and every single circuit is a type A device. So the fact that the RCD could be masked is not so much of a worry because there's no other circuits unprotected. Each individual circuit has its own MCB. So in that case, what would we code this as? Okay, you've got to ask yourself, is there a potential for danger, or is it just not quite right and we should really make a comment, maybe an improvement? How would we deal with that? Not sure if anybody's interacting with us at the moment, Frank.
Got a few C3s coming through, a couple of F5s and C2.
Okay, let me just get back to the slides and reveal the code. Yes, we've gone with the C3 for this application because apart from it being not really configured to the intended purpose, every circuit has additional protection with a nice modern RCBO to type A there. Should one of those spare ways get used, then the installer would not be doing it correctly because he'd be relying on that type AC device, and there could be presence of DC on those other devices. So yeah, it's something to watch out for, and we're going to see more and more of this in the industry as we move forward. Okay, next up. Right, okay, Frank, I'm going to hand over to you here. I think there's been an alteration. Did they say that there was the sockets moved because there was a doorway cut into the wall?
Yeah, this particular one, there was an alteration in an office building on the area and extending through a new doorway. And where we see the two cables that are cut off, they were going down to a socket that was in the place where the doorway now is. So the builders cut it off and they've joined the two 2.5 20.5 cables with the old porcelain screws as you used to have in the imperial days. I know you can still get them nowadays, but sort of they put two porcelain screws on the line and neutral, so the red and blacks. But the CPCs have just twisted it together, and it's very unlikely to be making a good connection. So you've got a possible ring continuity problem with the CPC, and you've also got unsheathed cables exposed up in the roof void where there's some timber and other flammable materials around there. So it's been purely done just to get the door frame put in. It could have been quite easily put together properly in a proper termination box, properly fixed, everything secure. But obviously somebody's had some old terminations in their box someplace and decided just to carry out an ad hoc repair.
Okay, thanks, Frank. Yeah, I mean, it is a requirement of the wiring regulations to have termination supported and enclosed. And when we refer to single insulation, we're talking about that basic insulation that's on show. When we have a sheathed cable, it's insulated and sheathed. Once you remove the sheath, you're removing that kind of mechanical protection. So therefore, the single insulation needs enclosing as well. And as Frank says, we've got very poor continuity, the adequacy of that termination, and terminations need to have suitable mechanical strength. So we're going to need to code this. So we're going to ask ourselves, could I get a shock off of it? Is it immediately dangerous, which would warrant a C1? Or has it got the potential for a danger, which would be a C2? I think we're looking at one of those two codes. Is anybody wanting to take a guess there?
Yeah, we're getting a lot of C2s coming through on this one.
Okay, great stuff. Let's do a reveal. Yeah, it's a C2 all day long. So that's great. Let's see what we got next. Okay, so this is a bit of a different one. We've got a hole in the meter cabinet there, you can see, and a bird has flown in and built a nest. Now, you do have to inspect the DNO's equipment as part of a EICR, but it's a visual inspection only, isn't it, Frank?
Yes, you're looking at visual and you should report any damage or any problems with the supplier or distributor's equipment to the person that's ordered the work. And then they should inform the supplier or distributor to carry things out. In this situation here, we've got a bird's nest because there's a hole in the cabinet. What you'd be looking at doing is cleaning the bird's nest out and probably repairing the door in the cabinet to try and resolve the problem. But it may be a case the distributor might need to put a whole new cabinet in because those doors might be obsolete.
Well, you know, you're starting to see some retro doors now that can be put over the top of cabinets, and contractors have different ways of repairing these things. I've seen that quite a lot. But first of all, I think it should be noted that when you do find a bird's nest, sometimes there are certain requirements in place. I'm not a sort of a nature boffin, but I do know that you can't just go clearing them out if it's an active nest, can you? You know, if there was eggs in there or whatever, you'd have to seek advice. So there's all those sorts of issues, but let's just say it is an old nest, and as Frank says, chances are you could just sweep it out. But you've got a problem with the door because it could happen again. So what we're going to code that one as then? Anybody want to join in?
I've got C3s coming through and NA, so majority C3s.
I get the NA, but I think it would be a good recommendation to make just to have that door repaired. So, you know, an NA. And let's face it, if the weather was driving in there and that bird's nest started to become wet and damp, it wouldn't be a great thing to have wrapped around that service head, you know, being wet and damp. And, you know, if it got any bigger, it might possibly track out there. So, yeah, it needs attention. It needs an improvement. Okay. So, next up, we've got Frank. Do you want to go through this one? Actually, give my voice a break.
Yes, we've got. This is a industrial unit where we have somebody's installed armour cables in the top of the contactor, and we have a situation where they have not used steel or armoured lines to terminate the cables, under the impression that we've got separate CPCs, so you don't need to have lines fitted to the cables. Now, obviously, SWA cables must be terminated with the manufacturer's glands that are provided or recommended to be installed for there. By having cable just coming in the top of the unit, you've got IP issues at the top where debris and dust and etc. can come in the top of the panel. Then you've got continuity issues on the armouring of the cable if it's not connected to the panel and provided with an earth tail. So going forward, you've got no protection for the armour cable as it's supposed to have. And if there was a fault, the armouring could become live. Within the contactor itself, you could see the state of the terminations as well, where some of the terminations haven't been securely terminated. There's a bit of copper showing on different parts of it. So there's a few different issues here. You've got no glands, armour in the earth, excessive copper on a couple of cables, L2 and L3. So there's quite a bit of issues on this one. So we're looking at coding of this one.
Yeah, I mean, it's quite a sort of topical thing, really. Quite often when we look at enclosures, a lot of contractors use the international protection of IP X4, don't they, or 4X or whatever it is, the 1mm diameter cable on the top. But there is also the difference with the XXD, isn't there? You can comply to XXD, and that means that a probe can enter, but it mustn't touch live parts. So there's a lot to take on board when you're looking at this, but I think you've pointed out there's so many observations here. We can definitely point towards giving a code for this. So what we got? Anything coming through, Frank?
We've got a code, some C2s, we've got C1. One thing to say about it, the move for purposes. So the cover was in place when it was inspected.
Yes, we always have to say that in these presentations, don't we? Because people see it and they think the cover's missing, there's access to live parts, but that's not the case. So, okay, so you've got a few C1s, C2s. Okay, let's reveal the code. Okay, yeah, C2, it's got all the potential for danger there, but it's not currently going to, kill anybody as it stands, but it's got the potential should something else happen. So that's our C2. Okay. Right, next up, we've got a lot going on in this picture. Now, let me try and remember which one feeds which. If you look at the top of the main switch and you look at the phase conductor, the line conductor, the brown one there, it's not actually, it's being fed from the neutral bar. So we believe, I think might be the bottom right-hand cable comes in and feeds this consumer unit. And it's being used as a junction box on that neutral bar there, okay? So there's other submains that are leaving this position with no protection. There's no overcurrent protection there, or fault protection. And it's just not configured correctly. We've also got mixed components, which is another requirement of the wiring regulations. Come in with the 18th edition where if you want to mix and match components, you need to get the manufacturer's approval, or you become the assembly manufacturer yourself and you take on all of the corresponding obligations. Okay, so that's something to be aware of. But this case, we're going to code it on the fact that it's not configured correctly, and we've got those line connections, terminations on that neutral bar up there in the middle of the consumer unit distribution unit. Okay, so what would we code that at? Anybody wanting to take a guess? Okay, now remember the cover's on ordinarily for this. Okay, what we got coming through, Frank? I can't see it this end.
Mix of C1s, C2s, FIs.
Okay, C1, C2s. Right, let me reveal the code. We've given it a C And the reason for this is, as an inspector, or if one of your employees was to go to a consumer unit, they would expect to isolate main switch. Okay, they may even prove the underside of it, which they should do, safe isolation procedures, etc. And ordinarily, apart from the terminals at the top of the main switch, you would expect everything else in that board, safe isolation, to be isolated. We've got a very exposed terminal at the top there that is still going to be live. So from that aspect, we're going to say this is very dangerous. It's a very dangerous. And this goes back to the engineering judgment that we spoke about right at the beginning of the presentation. The inspector has to take all the external influences into account and escalate the code from where he may or may not normally sit it. So that's where the Napit Codebreakers gives you the 9 times out of 10 code that should be used. But by all means, if you're on site and you feel, there's control measures in place, only skilled engineers are on in this building, you might be able to sort of lower the severity of the code. And likewise, if you're in a property and you think all the tenants are, they're likely to cause a problem here, you might want to upscale the code. So it's very much down to the inspector's discretion with all of this coding observations. Okay, next up, a damaged flexible conduit. It looks like a sort of kitchen, commercial kitchen, and you can see all the trays and the things underneath getting pulled in and out, and it's yanked the copex, or the conduit, should I say, out, and it's exposed those single insulated conductors. Okay, so what would we code that as? What are we going to say for that? Commercial environment, is it going to have ordinary persons using that? Yes, it's going to be a chef going in and out. It's not going to be electrically skilled. Is there a likelihood that they could pull a live cable out and it'd be flapping around? The single insulation could get damaged and could expose them to a shock risk. So there's a lot going on there. What are we going to code it as? What are we seeing, Frank?
Majority of ones coming through are C2s, a couple of C1.
Okay. Yeah, it's got the potential for danger. It's not currently danger present, but it's got that potential for danger. And remember, when you give a frequency for an inspection, depending what you've given it, but it may be a year, 3 years, 5 years, whatever, that's a long time to wait until it next get inspected. So something like this, it's satisfactory. It's just deciding between the 1 and the 2 that inspectors need to make the decision. And in this case, it's got the potential for danger. Okay, next up, we have got a fused spur with some thermal damage. Looks like we need to do a bit of digging around, a bit of investigation. What do we think we've got going on with this one then? Possible overloading of the circuit, maybe, or was it a faulty appliance? Maybe just a loose terminal. How would you deal with this one? How would you code this? For anybody who's got the eagle eyes there, you'll see that the little ferrule on the right hand screw has come out of the box as well. And from my days of contracting, when that happens, that's a right pain. It starts going squeaky, jams up, and you've got to end up changing the box because it's no good anymore. But that's not the observation. The observation here is this possible over. What we're going to call this one then, Frank?
Got some C2s and FIs.
Okay. Exactly that. You can't just say it's a C2. The repair guy comes along, strips the cable back, reconnects it. There may be an overloading somewhere or a problem that's causing this to happen. So that's where that FI comes into it. But both codes are unsatisfactory anyway until that you've resolved the situation. FIC2 yet. Okay, so we've got a situation where somebody's made an alteration here. If you look at the left-hand picture, what they've done is they've put RCBO in there. It's not the same brand, so we've got that issue we talked about earlier, because you don't know how good the connection is on the bottom, whether it's the venting the correct way, the device when it operates and it lets go. So there's all sorts of issues here that only a manufacturer would be able to comment on. But the observation we're looking at is the fact that took that cable out the front of the board, so there's probably some damage to the enclosure. They're straining on the terminations there. It looks like it's an SWA cable and it's just been taped up around the metal strand, so it's not been glanded correctly. Okay, so there's a lot going on there, and then it goes off and it feeds the box on the right hand side, which has suffered terrible damage because it's not glanded correctly and it's just been pulled around and it's cracked and it's broken. So there's IP infringements there as well. You'll notice there's a spare strand in the SWA conductor that's just left there floating, cut off. That's not really best practice because you can get induced voltage onto spare strands. So if you get spare strands, they need to have a safe end on them, and quite often what used to be old practice would be to actually color code them green and yellow and put them down to earth. I don't know if that's a practice that we still see today. Frank, you got any comments on induced voltages?
There's still some comments, any on the connected to earth to stop those circulating currents that can be induced in those conductors. Again, it could be voltage in there. You can cause some problems to some cases when it goes through. So it's always a recommended advice for unused cores to either be terminated to earth and labelled up as that and marked so it is identified of what they actually are.
Okay, right. So we've got a lot going on there. Have we got any codes, any sort of suggestions on what we would or how we would code that?
A couple of C2s come through.
C2s?
C2s we're looking at, yes.
Okay, let's reveal the code. Yeah, C2. It's got all that potential for danger. It's not, we're going to assume that you couldn't push your finger in that box on the right hand side and touch anything live. So we're going to make that assumption there with the size of the cables, etc. And assume also that usually when those lids are screwed back in place, it's probably keyed into the box itself, holding it slightly stiffer than what we're looking at there now, but it's got the potential for danger, C2. Okay, so we're going to look at this one here now, and just put a comment there saying who needs a spare way, because how else do you sum this up? Basically, we've got a cable there. It's been jammed into the bus bar side of the MCB to get a feed to run out to the left hand side to the triple pole breaker there that goes off to do something else. So we've got to ask ourselves, what is that something else doing? We've got a very short submain cable that's got no protection. It's just fed straight off of what the incoming supply is fused at. So we may need to look at that, and you know, there's a fair bit to be going on there. And this is a kind of sort of dangerous situation that we see from time to time. Usually happens in these types of workshops, you know, car workshops, car mechanic type of thing. Somebody needs an extra feed for something that goes in. They've got a little bit of knowledge, but not a great deal of knowledge, and we end up with a situation as what we can see on the screen here. Codes coming through, Frank.
Yeah, we're getting a couple of C2s coming through on that one. Yes, mostly C2s coming through.
Okay, great stuff, and I totally, it's a C2, but we've also put FI because you may need to look further, see what that submain is supplying, see that that's adequately installed, because this circuit has obviously been sort of jammed in there by somebody that doesn't really know what they're doing. You would want to look a bit further and see what's going on there. You can see the blanks not fitting properly in the front of that enclosure on the left hand side there. There's also a lot of dust and grime going on, which usually happens in a sort of industrial environment. So maybe the switch gear, you know, should be enclosed a little bit better than what it is. So there's things you need to be checking there, but it certainly is a C2. Okay. Well, that sort of brings us to the end of the coding session today. Now, myself and Frank are on here. We can take any questions if anybody wants to send any through. And whilst you're thinking about those questions, I'll just let you know about our suite of publications that we have. We've got the Codebreaker, which is the industry-leading coding book, which I've alluded to already, and it gives you some good advice on how to approach EICRs. It gives you about 700 codes, and it also covers some other testing requirements, risk assessment, frequencies of testing, etc., are covered in depth in the back end of that publication. We also have a risk assessment and management guide. We've covered a guidance on the private rented sector because that's very sort of busy at the moment, and there's a lot of landlords out there that needs guidance on that. So this is a book to help landlords understand and help inspectors be able to show their landlords this is what's required. We've got the on-site solutions publication. I'm actually the author of on-site solutions, so that was a guide that we put together for our contractors to show them how to deal with meeting the challenges of the changes in the wiring regulations. And our latest guide is for initial verification and periodic inspection and testing. So they're all available on Napit Direct if you want to have a look at the shop there. I would recommend that all day long. Of course, I'm going to say that. And I don't know if you've got anything to add, Frank. Is there any questions coming through?
I've got a question coming through. We've got a question. Somebody's asked, what do you do when you got a high ZE reading? And the figure they've given me is 1.33 ohms on a ZE. Yes.
Well, first of all, we've got to know what earthing system we're talking about. That would give us sort of some indication. I'm assuming it's a TN system for them to be stating that it's high. Well, usually it's for an inspection point of view, you get to the situation where you need to get the DNO involved, don't you? You need to ask the DNO if it's something that's out of your control and it's their earth they're supplying. You need to flag it up to them.
Yeah, as mentioned, it's a TNCS on TN systems has come across on that side of it. So it's not
now the guidance in the industry, we typically say that it's 0.35 for TNCS and 0.8 for TNS. But DNOs can go outside of those parameters if they so wish. They might have a TNCS the line, and you might be slightly over 0.35, but only then can say whether it's satisfactory or not. And of course, once you start to get up to the kind of level of, what was it quoted, 1 point something there?
1.33.
Once you get up to 1.33, then you're not going to achieve shock protection with your MCBs, are you? You're going to need to get fault protection reliance on an RCD there, because you're not going to meet your, especially the bigger circuit breakers. What is 80% of a, say, a B type 32 is about 1.1, something like that, Frank. Just straight away you've got problems with your ZS reading. So all you can do really is you can contact the DNO to see if they can check to see whether it's a dodgy joint somewhere and they can repair it and improve the earth. If not, you may have to be looking, if they disown it, you may have to be looking at other measures such as the installation being turned into a TT installation because the TN system is being deemed to be unreliable, in which case you need RCDs for fault protection, and it goes on and goes on. So it's not an easy question to answer that without knowing the site specifics, but hopefully I've given you a good indication of what you should be thinking about.
He's followed up with that one. If it's during an EICR, would it stop my EICR and would it fail? It would depend on what the protection was in the property. If you did have all RCD protection within the property, you would put it down for possibly further investigation with the DNO. But if there was RCD protection, that would provide the additional protection for the circuits within the property. Obviously, if there's no RCD, then it could lead to other issues, and it may be that yes, you'll be putting it down as a fail. You've got a high ZS. ZE, and that could be affecting your ZSs within the property, which then that would lead to an unsatisfactory situation within the property itself. and would require either further investigative work or some other action to be taken to make the installation safer.
The thing is with test and inspection, you've got to look at all aspects of it, haven't you? If you're looking at your R1 plus R2 of the circuits, and they're acceptable and within the range of what you would expect them to be, okay, and you've got this problem with the ZE, then you've got all the information you need to be able to hand the client the report and tell them why it's unsatisfactory because you've got this RFM problem. The issue is if you deem the client to be at risk because of the problem, that's where you escalate the report to more of a severe code to be able to get it dealt with because it is a problem. So yeah, RFM is a problem, but DNO is the first port of call because they might send somebody out that can say, yeah, we've got to improve this joint in the cable, or we've got to change the service head, and we can provide you a cable with intolerance. So yeah. Okay, any others, Frank?
Just let me see if any others coming through. No questions coming through at the moment.
Okay, well, if we've got nothing else, it's a little bit shorter than I expected. I had sort of allowed for a bit of time so that we could take some questions. Myself and Frank cover all aspects of electrical contracting, so the questions, we can open up the floor to any questions. It doesn't have to be just on EICRs. We can talk about any sort of BS 7671 electrical requirements that you may have. If anybody wants to ask any questions about the services that we provide, we are training services, inspection services. We've talked about the publications already. Insurance, we cater for everything at Napit. So any questions? If nothing comes through within the next couple of minutes, we can draw this to a close, and thank everybody for watching.
There's no one come through. No one's come through. If a tenanted property, non-HMOs, has an old cartridge fuse board with no RCD protection, this would be a C2. That would be the provide on that one. So if you've got the fuse board, no RCD protection.
No RCD protection. Well, it depends. When you start looking at RCD protection, you've got to start looking at what the requirements for having the RCD in the first place is. So, for example, in the 16th edition, only sockets that could be used outside were requiring 30 milliamp RCD protection. Okay, so it wasn't every socket outlet needed it. It's only in more recent times. So generally, when we have a socket outlet with no RCD protection, unless it could be used outside in a dangerous sort of location, mowing the grass or whatever, we would always recommend it as a C3, but we wouldn't necessarily say it's a C2. But if you start to look further and you're seeing cables that are in vulnerable positions in the wall, less than 50, you might say, well, now we're edging towards a C2. Or it might be that you're looking at the bathroom and there's no supplementary bonding in place, which was a requirement of the 16th edition. And it's still classed as additional protection. You can still use supplementary bonding to this day, but it got relaxed in the 17th edition with the introduction of more RCDs. So it might be that you look through the inspection and say, do you know what, there's no supplementary bonding, there's sockets that could be used outside, and then that's how you would justify your C2. Inspectors need to be able to justify why they're given the codes, but for us, they've always got the technical helpline to fall back on, or the code and publication, which is Napit Codebreakers, that they can turn to their clients and say, this is why I've given the code, because it's here in industry guidance. So that's how to approach that.
Yeah, one is somebody's asked, is a new publication available as digital download? Yes, it should be available as a download. The printed copies have all gone out to anyone that's pre-ordered, and the digital copy should be on Vital Source. If you buy it from the Napit Direct, you get a digital copy for that one as well. We've got one here, which is one that does often come up on Codebreakers, which we won't get away from it. we've got one here why Codebreaker says code C2 for buried cables. Now, within that side of it, we've got a situation where on an EICR, for cables concealed in the fabric of the building, within EICR, it says you're not inspecting them. So it's down as a limitation to start with. So you're not inspecting for buried cables. And that's unless your client specifically agrees for that. And the reason we've got a C2 in Codebreakers for is where you come across concealed cables and you can see there's areas where they can be damaged, and people have put up shelves or picture frames, and there is damage or potential damage for those cables, because there has been instances where people have had shocks and people have been injured and killed through cables pierced within concealed in walls. And that's why we've got a C2 in there. If you come across cables, they're liable to be damaged. That's why it's down to C2. It should be initially down as a limitation because you can't get into the walls to see the cables anyway. So initially, an EICR should be a limb, but if you inspect for cables and see they're liable to be damaged, that's why we've got it down as a C2.
Yeah, I mean, we use RCDs for additional protection in those types of environments for carelessness of users, don't we?
Yes, that's right. Yes.
Okay, so this is what we're talking about. When you have different clients, you may be looking at some clients and you feel, well, do you know what? These are not liable to be, making alterations and this, that, and the other. You may look at other ones and say, do you know, there's tenants in here. They're doing this, that, and the other. I'm not sure. And the RCDs are there for carelessness of users. So we are where we are.
Yes. So that's what we've got in there. Another one there is a board without an RCD is a C2 or C3. I think we've already covered that. Depending on where the board is, what type of property it is. If it's 14th floor flat, you may not need RCDs on those circuits. There's no danger, but if they could be used outside, yeah, you'd be looking at a C2 for that. One of them is talking about smoke alarms. They don't form part of the PRS regulations. That's correct. The fire detection systems do fall outside of BS 7671 for their operation. The installation of cables for fire alarms and emergency lighting, etc., do come under 7671, but the operation of those systems do fall outside of 7671. So for fire alarms, it would be 5839. For domestic, it would be Part 6, and for emergency lighting, it would be 5266. So they're separate British standards that need to be followed when you're carrying out inspection and testing for those type of systems. Got one more there. Sorry, just pick up, Paul. Sorry. Quite a few coming through now. So, if you change your fuse board, do you have to upgrade the earthing from 6 mil to 10 mil on a TNCS system if there are no thermal conditions and the earthwire's okay?
There's two very different things here. When you do an EICR, you're reporting on is it safe for continued use, and it's an existing cable, and you've looked, is there any thermal damage, etc., etc., then you may put it through as a recommendation. But when you're doing a fuse board change, you're doing initial verification, and the regulations are quite clear. They talk about alterations and additions and the adequacy of earthing. So yes, if you're doing a replacement fuse board and it's a TNCS system and your earthing is not at 10 mil, yes, it does need to be upgraded, unfortunately.
Yes. There's another one. I think we've covered that about the fuse boards and RCD protected. We've covered that one. We've got one here. Why are ECRs and PRS not registered like new fuse boards? I've seen some bad drive-by from different companies, but yes, the PRS regulations don't. It's not part of a competent person scheme, and there's no requirement for notifying the work. What you have to do is the landlord has to provide an unsatisfactory EICR along with any remedial work from that EICR, which is certified under an electrical installation certificate or minor work certificate, and the landlord has to provide that to the local authority. The local authority can also request a copy of a satisfactory EICR if they so wish, but there's no requirement to register every EICR that's carried out in the PRS property. It's not something the government have decided to do, like under Part P, where any new work in alterations, additions, and special locations have to be notified for the work carried out. So it's not a case of notifying PRS regulation EICRs. And now I've got here. What code with a light in a bathroom if it doesn't appear to be IP rated?
Well, you need to look at the requirements of section 701 first of all to see what the IP ratings are, and I think it's if it's in the zone, doesn't it? It needs to be IP44 or something like that, and if it's subjected to water jets, then it's IPX5. So if it's outside of the zone, then you could argue that it doesn't need an IP rating, but I think we do like to see equipment that's fit for purpose, really, don't we, within a bathroom location. So I think if it's outside of a zone, then, but it's not really a great looking light fit, and you might want to recommend it for improvement. But if it's within the zone and it doesn't meet the IP requirements, then it doesn't comply. So then that's where you may put it down as a C2.
Yeah, there's one here now on PRS related where been told by the landlord we should be carrying out the EICR to the regs that were in place when the property was built. It says i.e. 15th or 16th. Well, the PRS regulations refer to BS 7671 2018, so the 18th edition. So the EICR must be carried out to the 18th edition regulations. It doesn't mean to say the installation has to be up to meet the requirements of the 18th edition. It doesn't need to be upgraded. It just needs to be checked that it's safe for continued use based on the 18th edition law and regulations. And that's always the case when you have a change of regulations. You test at the current edition, not the previous editions, because those regulations are no longer applicable. You need to comply with the current edition. A couple more. Where's one, Paul? Would allow a washing machine in the bathroom if it's hardwired to a spur outside the room?
A washing machine in the bathroom?
Yes.
Well, I mean, the 701, I've got my regs here, I'm going to put up. It does give you some examples of what equipment can be within certain zones within the bathroom. And we do see from time to time washing machines and boilers and things in bathrooms, don't we? So what you've got to do is you've got to ask yourself is, do the regs permit that? Will they allow it? What zones? So let me just do this. We're going to do this live on the spot now. I think that we'll have to make this the last question, Frank, because we're encroaching on the time. Current use of equipment, blah, blah, blah. In zone 1, only the following fixed equipment is connected, whirlpool, showers, etc., blah, blah, blah. Zone 2, switchgear, accessories, and corporate switches, socket outlets, blah, blah, switches, socket outlets, source being outside the zone. So there's nothing in the regs about washing machines. Personally, I would say it's not going to be in zone 1, is it? It's not going to be in the bathtub with you. We'd like to see that outside of zone 2, but if the socket, did you say the socket was outside of the bathroom, a Spur?
The Spur was outside the room. So
yeah, I can't personally see an issue with it if it's outside of the zones. Okay.
The only issue you would have with it is if the manufacturer instructions stated it wasn't suitable for installation in the bathroom.
Yes.
That's what you need to look at on that side of it. And some type of white goods equipment are not suitable for that type of environment. So the manufacturer would need to confirm that on that side of it. So yeah, we're getting close to the finishing time now, Paul.
5 minutes, Frank. Is there a quick one you want to squeeze in, or
one last one? I think I'll find it. What is the minimum size of main earthing need to be? So again, that would depend on the type of earthing system you have in the property. So you've got the different tables within the regulations. It gives you guidance on the requirements for the minimum size earthing conductor. Paul? TNS or TNCS. So.
Yeah, quite often the tables are in the tables are in the regs, but quite often sometimes when from an inspection point of view, we might have to look at a adiabatic equation, because just because it doesn't meet the table doesn't necessarily mean it's unsafe if it's been designed. Remember, when we look at protective conductors, we can use the adiabatic equation, or we can use the tables, and the tables quite often result in us using an oversized cable. So just because an earthing conductor is smaller, it doesn't necessarily mean it doesn't comply, providing the requirements of the adiabatic equation are met. So sometimes you've got to do a bit of maths to calculate it out. But like you say, the guidance out there quite often these days, I say 25mm towels, 16mm earthing conductor, 10mm bonds. That's all well and good when you're doing a rewire, but when you're doing an EICR, you've got to look: is it safe or unsafe? And that's why sometimes you have to look at the design criteria. And it does, it is a pain, but it's something that's well explained elsewhere. We've covered it certainly covered it in the Napit on-site solutions in the design section. So I think that's all we've got time for, Frank. I would just like to thank everybody for showing an interest in Napit and watching this, and thank ECN for having us, and thank